Alright, hello. In this video I'm going to be recording solutions for BC Homework 1.0. And I think before I start, I just want to remind you that there is going to be a quiz next time, but it's not really over this, and it's still not going to be counting for a grade. It'll be algebra and trigonometry, but not really exactly the same as this. Really just more opportunity for you to practice grading so that once we start doing the calculus, you'll be ready to rock. Alright, so let's start off. Suppose f is a function given by f equals 6x squared plus 6x minus 12. What are the zeros of f? Okay, we can do this. A zero of f is a place where f equals 0. Okay, so I'm going to set f of x equals 0. 6x squared plus 6x minus 12 equals 0. You know from a long career in algebra that we can't just solve this thing directly. We're going to need to factor, use the quadratic formula, and I'll tell you in this class, quadratic formula is hardly ever the thing to do. So we're going to factor. So what can I factor out of everything? That's a 6. Okay, and now it's looking a little better, right? This is going to be x plus 2, x minus 1. And this is going to happen, this is going to be equal to 0 anytime any of these things is equal to 0. So either 6 is equal to 0, which that doesn't sound very likely, or x plus 2 is equal to 0, that could happen. Or maybe x minus 1 could equal 0. And then this would give us either 6 equals 0, which of course it doesn't, or x equals negative 2, or x equals 1. These are the zeros of f. All right, suppose g is the function given by g equals 6t to the 4th minus 6t to the 3rd minus 12t to the 2. Okay, so this looks very similar. I'm going to need to factor it again, but then instead of just a 6, it's going to have a t squared I can factor out as well. And we are looking for where is this guy positive and negative. This is the thing we're going to need to do frequently in this course, is take, like a polynomial or some other type of function and determine where is it positive and where is it negative. Okay, so let me just copy the function. Okay, so 6t to the 4 minus 6t to the 3 minus 12t to the 2. All right, excuse me. I'm going to start by factoring. I can factor out a 6 and a t squared. So this will be t squared minus t minus 2. Okay, so this is going to factor a little differently from the earlier one, but mostly the same. I think it'll be t minus 2, t plus 1. Okay, so t plus 1. Okay. Now, in order to determine whether this is positive or negative, we kind of have two options. I'll show you both of them, and I'll tell you that I prefer sketching a graph, because it's really fast. Okay. I know that this thing has zeros when t is equal to negative 1, 2, and 0. So I'm going to go over here. So this would be negative 1, 0, and 2. Okay. This is a 4th degree polynomial with a positive leading coefficient, which means to me that it's going to look, at least on the outsides. Hold on, where's the camera? Yeah, it's going to look like a parabola, right? So it's going to come from above, and then it's going to eventually go back up. Okay. Since these are both single roots, it's going to pass through the x-axis confidently, right? And then because 6t squared, because it's a double root, it's going to bounce there. And that actually looks like it's going to fit with my picture. And so I know that's kind of the sketch of the graph, right? Not a great sketch, but, better than what we started with, which was no sketch. So determining where is it positive, what values of t make g positive? G is greater than 0 for t less than negative 1. And also t greater than 2. Okay, you could write these as intervals if you like, or you could write them as inequalities. We don't care in this class. All right. So next, I'm going to talk about where is g negative. G is negative here, but not at 0. Okay. So I'm going to say -1 is less than t is less than 0, and also 0 to 2. 0 is less than t is less than 2. Okay. If you were willing to think that negative meant, just like not positive, like 0 or less, then you could say just from -1 to 2, and even including the endpoints. That's the type of distinction we're really not going to be getting into in this class. Okay. Alternatively, you do have another option. Let me get a different color pen or something to write with. Yeah, let's do this in red. You can also say, all right, I know what the zeros of this thing are. Again, -1, 0, and 2. And you could test values, right, to determine whether it was positive or negative. Because if you just chose a representative from each of these subintervals, one of the facts that you learned in algebra is that the only possible places a polynomial can change signs are at its zeros, basically because of its continuity. So if you just test one representative, like say here we test x equals 1. Let's start with that. At t equals 1, when I plug in t equals 1 here, I'm going to have positive, negative, positive. Oh wait, positive, negative, wait. Positive, I'm running out of room, but you see what I'm saying there. 1 negative makes negative. Okay. Maybe something bigger than 2, like 10. T equals 10. At t equals 10, I'm going to have positive, positive, positive. Over here, between -1 and 0, I'll choose t is -0.5. And I'll say, okay, positive, negative, positive again. Okay, so that's going to be negative. Positive, negative, positive. All right, and then over here to the left of -1, say like -10. That's going to be, okay, positive, negative, negative. Negative times negative is positive. So we're going to have positive up here. And you come to the same conclusion, right? I like this because it's faster for me, but if you don't trust yourself sketching the graph of high-degree polynomials, I understand that. That's fine. No judgment. And you trust this more, go for it. Whatever it's going to take. Okay. All right. Next, we are going to ask about this one here. This, oh, you can't see it. Oh, okay. You're actually you already have experience with this problem, right? Because I gave you a geometry quiz on the first day of school. Again, really just to kind of give you something to grade next time. But I'm going to jump in and work this one for you and show you how it's done. So this is number 3. I guess. What? I might work this on a Post-it note. Hold on just a second. All right, so H consists of 2 line segments and a quarter circle. You see the graph. Where is H positive and decreasing? Okay, H is positive from 0.5 to 5, and also -2 to -1. Okay, it is positive and decreasing here and along the quarter circle. So I'm going to just say for x between -2 and -1. Maybe I'll write it as an interval this time, right? -2, -1. But also union 2 to 5. All right. Okay, and then what is the area of the region in the first quadrant enclosed by the graph of H and the x-axis? Okay, that's kind of a loaded question. I think, oh, no, they said in the first quadrant. No, that's fine. Okay, I thought they meant for 0 to 5. That's something you probably don't know what to do with yet. Like, what do you do with that as opposed to that? Okay. So what we're going to do is we're just going to find the area of basically this. this region right here. And how we're going to do that is we're going to split it in half, or not in half, but we're going to split it up into two shapes that we know the area of. Okay, so on one hand, we've got this right triangle. The right triangle has width 1.5 and height, what is that, 3. Okay, so that's 4.5 divided by 2 is 2 1/4. I'm going to call that 9 divided by 4, okay, because this is going to be 9 divided by 2 is 3 times 1.5. And then I'm going to divide by 2 because it's a triangle. So that's... Okay, now this thing, it's not the area of the circle, right? It's like the area of the square with the circle cut out. Maybe I'll just draw a little square in blue. Probably should have done red. Doubt that's showing up very well. It's okay. Okay, so the square has area, what is it, 2 to 5 is 3, times 3 is 9. Okay. And then the area of the quarter circle is 1/4 of pi r squared. So maybe I'll just say 9 minus 1/4 pi r squared. Okay. So this is 9 minus 9 pi over 4. Okay. Again, we could do arithmetic on that. We could say that 9 is 36 over 4 plus 9 is 45 over 4 minus 9 pi over 4. You could call it 45 minus 9 pi, all divided by 4. You know, really whatever you want. It's all the same number. Okay. Maybe move on to number. All right. Yeah. So for what values of t between 0 and 2 pi does cosine of t equal negative root 3 over 2? Okay, it's an old-fashioned pre-calculus question, right? But you know, if you're not like super strong on the unit circle, I'm not going to say like, oh, that's no cause for concern, or oh, you won't need that this year, because you will definitely need that this year. But we're going to practice it frequently enough that I wouldn't, you know, don't drop the class because you don't know a trig, right? Just we'll practice it every time and you'll get stronger and stronger. I should also point out that quite a few years ago, I had a student in my Cal BC who moved in from a different state where he went to some like, you know, technical school or something where they just threw all the 9th graders in calculus AB. And I don't know what the reasoning was for that, but he took AB as a 9th grader without any trig. They didn't give him any trig first. He said all he pretty much knew was that, you know, like sine of 0 and cosine of 0 were 0 and 1 respectively, and that cosine was the derivative of sine, which you don't know yet. And he said he was still able to get a 3 on the AB without knowing any trig. So, I mean, not going to hold you back. Okay? It'll just keep you from, you know, being as successful as you want to be in this class. So cosine is negative root 3 over 2. I'll show you how I do. I mean, I'm sure you have your own techniques for solving these trig equations. But I draw the unit circle. Right? And cosine is the x-coordinate. And root 3 over 2, that's pretty big. That's the next biggest thing to 1. Right? It's not quite 1, but it's the closest thing we have on the unit circle. So what I'm going to do is I'm going to say, okay, x is negative root 3 over 2, which is really close to 1. So I'm going to just mark it like really far over here, right? And then I'm going to say which spots on the unit circle have that x coordinate. Well, then I can go up and down to scan and find them. And now if you actually find out what is the decimal value of root 3 over 2, it's not that close to negative 1. But if we plot it over here, actually where it's supposed to be, it's not as clear. Am I talking about 3 pi over 4 or 5 pi over 6, right? If we draw it really far, it's obvious which stop on the unit circle we're talking about. It's not pi because it's not negative 1. It's almost negative 1, so it's the one almost 2 pi, which is 5 pi over 6, and then the next one after is 7 pi over 6. So I'm going to say cosine of t equals negative root 3 over 2 when t equals 5 pi over 6 and when t is equal to 7 pi over 6. Okay. Okay. Now the last one, this is just like, do some algebra, work some stuff around. I think I'm going to actually just work this on the sheet of paper. Solve for x in terms of y. Okay, except for the last one. The last one, well, I mean, if you're good at completing the square, you could do that. Maybe I'll show you how you would do that, and I'll show you what I'd actually intended to put. And this is the third year in a row I've forgotten to actually change the instructions on this problem. It's all right, though. Solve for x in terms of y. All right. First, I'm going to need to get rid of the 2, right? If you think about reverse order of operations, we're going to have to deal with addition and subtraction first, then multiplication and division, and then exponents and anti-exponents, or whatever, So I'm going to say y divided by 2 equals e to the x plus 1. And if we've got something and we're trying to get at the exponent, that's where we're going to use a log. We're going to take the log of both sides, right? And I may have mentioned this in class, or I may not have mentioned this in class yet. When I say log in this class, I mean natural log, okay? It's the only type of log we really care about. We will do some things occasionally, by occasionally I mean like once or twice, with logs with bases besides e. But for reasons that you'll see coming up in the class, all logs are really natural logs. So I'm going to take the natural log of both sides, and that'll give me x plus 1. And then I will solve at x by subtracting 1 from both sides. So I'm going to say that x equals -1 plus the natural log of y divided by 2. For b, okay, this one will be probably a little easier. I'll start by subtracting 3. I'm going to need to divide both sides by 4. Okay, and if I have a log and I want to get rid of it, I'm going to take e to both sides power. Okay, so I'm going to say that x is equal to e to the, I'm going to write that as 1/4 of y minus 3. Just save myself some room. Okay. For c, y equals x squared plus 1. Okay. Well, I'm going to say that y minus 1 is equal to x squared. And then, well, if I've got this x squared, I'm going to need to take the square root of both sides of this equation. And, well, again, I'll be honest, I'm recording this before the first day of school, so I'm not sure what I'm going to talk about or what I'm going to get to on the first day. But when you take the square root of both sides of an equation, they generally tell you don't forget the plus minus, right? But maybe you don't, maybe you haven't really thought through why. Or, maybe you have, but maybe I'll show you something different. Okay, if we take the square root of both sides of this equation, then we're going to get the square root of y minus 1 is equal to, and then it's going to be the square root of x squared. And you may be there saying, like, I know what the square root of x squared is. It's x. And it's like, yes, but not always. Okay, let's just think about the square root of x squared. When x is equal to 5, well, x squared is 25. We're really taking the square root of 5 squared, and that's equal to 5. But what if x was negative, like -7 or something? Okay, if I'm taking the square root of x squared, I'm taking the square root of -7 squared. And if I square -7, that's still 49. Right? And if I take the positive square root, when we write down that radical symbol, we mean positive square root. So this is going to be equal to 7. And we're familiar with the type of mathematical operation that takes a number, and if it's positive, it doesn't do anything. And if it's negative, it strips away the negativity. That's absolute value. And so really what the square root of x squared is absolute value of x. And if the absolute value of x is equal to a number, then x is either equal to that number or the negative of that number, which is where we get the plus minus from. All right, and then, all right, d is y is 1/2 times the third root of x. Okay, this one will be pretty all right. That'll mean 2y is equal to the cubed root of x, meaning I need to take both sides to the third power. So x is equal to 2y to the third. And if you wanted to stop there, that would be fine. If you wanted to go farther, then you need to be right. Okay, you need to do this correctly. If I take 2y and I cube it, really what I have is 2y times 2y times 2y, which is going to be 3 copies of 2 and 3 copies of y. So x is equal to 8y to the third. Okay. Now, for e, I'll show you what I'd intended. I actually wanted you to solve for y and not x. Okay. So, get y on its own, deal with the log and the absolute value, because believe it or not, log of an absolute value is something that we're going to be dealing with frequently in AP Calculus. So, I'm going to solve for y, and then I will go back and show you how a person would solve for x, but I think you'll find it's pretty unpleasant. Okay, I'm going to need to go up here. So, if I've got, absolute value of y minus 1 equaling 1/2 x squared minus x, the first thing I'm going to need to do to get at y is get rid of the natural log. So I'm going to take e to both sides power. So absolute value of y minus 1 is equal to, let's see, e to the 1/2 x squared minus x, all in the exponent. Okay. Then I'm going to get rid of the absolute value. Okay. And if we do that, then we end up with plus minus on the other side. So y minus 1 is plus or minus e to the 1/2 x squared minus x. And then I'm going to solve at y by adding 1 to both sides. All right. And I think now, I don't want anybody to get the wrong message here when I solve for x, because it's going to be a lot. And so I think I'm just going to kind of flash up I'm going to pause the recording, work it out, and I'm just going to flash it up on screen so that you could pause and see how you would do it if you had to. But if you follow me here, that's all I need from you, right? This extra completing the square is honestly beyond what we have to do in this class. We do have to complete the square eventually, but by that time, you'll be good to go. Okay, let me find a different color. Perfect. Okay, so I'm going to pause. And so here it comes. All right, there it is. I completed the square. A couple of things that I might mention about completing the square, although it is not something that we have to do in this class. You need to have a leading coefficient of 1 to make it easiest on yourself, and then we need to add the same constant number to both sides of the equation to get a perfect square, and then when you take the square root, you know how it goes. All right, that's all I got.